Hi everyone, and welcome back to a new season of Science at Home. So in this first episode, we're teaming up with Heritage Week, and we're going to find out all about a Westmeath scientist from the 1800s who figured out a way to measure the temperature of the sun. Now we're going to find out a little bit about his background, and then we're going to head to the lab to figure out how could someone from the 1800s measure the temperature of the sun using just mirrors and magnets. So let's go find out. So we're here at Daramona House in the village of Streete, County Westmeath, and this was the home of William E. Wilson, and he's the scientist we're going to be learning about today. Now, with the help of this lovely book by Ian Elliott and Charles Mullen, I was able to learn loads about William Wilson, and he built his very own observatory and science lab here in the grounds of this house. So we're going to see if we can find them and find out what remains of them. Let's have a look. And here we're actually after finding William Wilson's observatory. So this is where he would have kept his telescope for taking all sorts of photographs and measurements of outer space. And the main thing you'll see here is a huge tall pillar of concrete. At the very top of that is where his telescope was. And this allowed him to keep his telescope dead, firm and steady so he could take really good measurements. Let's see what else we can find. Thanks to this book, we're after finding the exact location of the lab. We're standing in the lab right now. And look, nature has taken over here as well. But this is the spot where William Wilson would have measured the temperature of the sun by letting the sunlight in through these windows and analysing it here with all his equipment. So what we're going to do now is we're going to go to our own lab and we're going to see exactly how he did it. Let's go. And here we are in the experimental physics labs at Maynooth University. So the students were all away for the summer, so I thought we could come in here and try and recreate William's experiment. Now, the first step I'm going to take us through is understanding that the sun glows really bright because it's really hot. Just like if you get a piece of metal really hot, it'll glow really bright. So what I have here is an old-fashioned light bulb. They call them a filament bulb or an incandescent bulb. All that means is there's a tiny little wire in here and we pass electricity through it, which heats it up and it glows. So what I'm going to do is I'm going to turn this dial, which is going to pass more and more and more electricity through. As I increase the electricity, which increases the temperature, it gets brighter and brighter. I keep increasing the temperature, it goes to yellow. It's gone from red, orange, yellow. I keep increasing the temperature and it gets really bright. And it goes almost to a white. Now, what William thought was, if I could figure out what temperature, this little piece of metal that's glowing is, well then maybe I could connect the light from this and the light from the sun to figure out what temperature the sun was. So how hot it is. But how could you figure out how hot this glowing piece of metal is? There was 3 pieces of equipment that William was going to need to do this experiment. And we're going to go through all 3, and then by the end of that, you should understand how he did his experiment. Okay? So the first piece of equipment was called the heliostat. And we're going to go outside and have a think about what a heliostat was. Let's go have a look. All right, so the first piece of equipment, the heliostat. Well, what is that? Well, in order to analyse the light of the sun, William had to get sunlight into the lab. So we can shine that sunlight using a mirror, If we catch it just right, we can get that sunlight just glinting off our mirror and we can shine that into the lab. But the problem is the sun moves all throughout the day, And we want to have that sunlight constantly in the lab so that we can analyse it. So a heliostat is a special machine that's run by clockwork that will actually move the mirror at just the right speed so that it gives a constant stream of sunlight going in the window of the lab all day. And once William had that stream of sunlight coming in the window of the lab all day, he was able to carry on with the rest of his experiment. I want to show you what William did with the light that he was able to bounce into his lab. So he closed all the windows and doors just like we have here, and he had just a tiny little gap where that light was able to get in. Now he put that light through a lens and it made that image of the sun 80 centimeters wide. So he was able to get a big image of the sun just like this in his lab. And now what he wanted to do was, if he could come up with some sort of a detector that could somehow detect how much light there was at a particular position, he could figure out how much light is coming from the sun. Okay? But before he could get to that stage, he first had to develop this other instrument called the Meldometer. So now let's go have a look at that. Okay, so this is the Meldometer. Well, it's a replica of the Meldometer that I built to explain the principle, but it should do the job. So what's it for? Well, William had to be able to try and connect how hot an object was with how bright an object was. And the Meldometer was a way for him to do that. So what is it? Well, we connect up this little piece of metal here, see this silver piece of metal, to this battery. So it's the same principle as connecting up our light bulb to this power supply. When we increase the amount of electricity or the voltage, it gets brighter. So when William increased the amount of electricity going through these wires, the piece of metal got brighter and brighter. He was able to heat it up and make it brighter. So now he had a piece of metal that he could control how bright it got and how hot it got. Now what he wanted to figure out was, what temperature is it? How hot is it? And he couldn't measure that directly with a thermometer. It wasn't possible. It was just too hot. So he came up with this ingenious idea, and this is the key to the Meldometer. There's a little mirror sitting here on the top, yeah, and it's connected to all the little bits of metal. When a bit of metal gets hot, it expands. Just a tiny bit, but it gets a little bit bigger when it gets hot. So he knew that if he could somehow measure how much bigger that piece of metal got, he could figure out how hot the piece of metal was. But the amount it stretched by was just too small. So that's why he connected the mirror. If he shone a piece of light on this mirror, yeah, it bounces off the mirror onto the wall. And then when he increases the temperature, yeah, and this metal glows, it caused the metal to stretch just a little bit, and that is going to cause the mirror to twist, and the light is going to move against the wall. So the amount that light moves on the wall is an awful lot bigger than the amount that the metal stretches. So he was able to measure that. And using that, he was able to figure out what temperature the piece of metal was at when it was glowing. Okay? So it's still a bit confusing, but we're getting closer to the answer. So let's go have a look at the next piece of equipment. So William needed one more piece of equipment to finish off his experiment. He had the heliostat that bounced the image of the light into his lab and kept it there all day. He had the Meldometer that was able to tell him the temperature of a glowing piece of metal. And the last piece of equipment he needed is called a Differential Radiometer. Now you're probably wondering, what is a Differential Radiometer? Well, I'll try and explain it to you by breaking it apart into its most simple parts. The first part of a differential radiometer looks like this. It's two different types of metal joined at one end. Okay? And why is this so special? Well, if you increase the temperature of one end of these two different types of metal, you're going to create electricity at the other end. Now, I might be able to go into that in a later video, but for now you can just accept that. If you change the temperature of one end by heating it up, you're going to create electricity at the other end. So now this kind of weird device will create electricity when you heat it up. If we add one more element to it, a coil of wire. So I'm going to put a coil of wire the whole way down along it. And if we connect this coil of wire, yeah, to the two ends that are generating electricity, that means electricity will flow through the coil of wire. Now you might remember from my earlier video, I can give a link to it if you haven't seen it, that if you pass electricity through a coil of wire, yeah, you will generate magnetism. You can turn this into a magnet by just putting electricity through a coil of wire. Be sure to check out the other video if you haven't seen it. So now we can kind of think about this as being a heat-activated magnet. Yeah? If you heat up one end of it, it becomes a magnet. A very, very weak magnet, but it's still a little bit of a magnet. So we almost have the full device here. Let me just set up some bits and pieces and show you it when it's all put together. So this is the differential radiometer, believe it or not. Well, we know what this part is, yeah? It's the part we talked about earlier, which is essentially the heat-powered magnet in the center here. And it's hanging on a string with a tiny little mirror on the top. Okay, and it's inside of a big magnet. Okay, so this is a permanent magnet. And we can see that it has a north pole and a south pole, red and blue. Now we should know that opposites attract with magnets. So a south pole of one magnet will want to stick to the north pole of the other. So if we heat up the end of this device here in the middle, yeah, that will make this turn into a magnet with a north pole and a south pole. And it's going to twist to line up with the other magnet because it's going to be attracted, yeah? And because it's hanging on a string, it can easily twist. Even if it's only a tiny bit of magnetism, it can twist one way or twist the other to be attracted to the big magnet. Now, why is the mirror here? Well, he's going to use the same principle as before. He's going to bounce light off the mirror and see where it hits against the wall. And in that way, he can measure how much it twists one way or the other. Right, but how is he going to heat this up? Well, you know, if you go outside on a hot day, the light from the sun heats you up. Light can deliver heat. So he's going to shine the light of the sun just on this little end here. He can even put a little extra bit on top to make sure the light only gets through to the end. So he can control how much sunlight gets through. And that little bit of sunlight is going to heat it up a little bit, create a bit of magnetism, and twist it to be attracted to the magnet. We're almost there, but he still can't figure out what the temperature of the sun is. So he had to do one step further. This device in the center, it's called a thermocouple, and he actually put in two of them. One was upside down, one was the right way up. And why did he do that? Well, he wanted to balance the sunlight with the light from his piece of metal in the lab. If he could figure out a way of showing that they're exactly the same brightness, then he could figure out what the temperature was of the piece of metal, and he could figure out the temperature of the sun. So he had two of these devices, one upside down, one the right way up, and he shone the light of the sun on the bottom part, and he shone the light of his piece of metal on the top part. And when he shone the light from the piece of metal, it made it twist one way, yeah, because the magnet was flipped. And if he shone the light from the sun, it made it twist the other way. So what he did was, if it twisted one way, he turned up the voltage to his piece of metal to make it brighter until it twisted back. And if it twisted too far that way, he turned down the voltage until it went back. And he was able to see by watching the piece of light coming from the mirror on the wall, when it was exactly in the center, he knew the amount of light coming from his piece of metal was exactly equal to the amount of light coming from the sun and hitting here. And he was able to deduce from that the temperature of his piece of metal must be able to tell him the temperature of the piece of sun, because the two pieces of light were exactly equal. He was able to measure it here. So let's look at the next step, where he was finished the experiment and just had to do some mathematics. So now, the best part of every experiment, all the maths at the end. Well, so William was able to figure out that he could balance the amount of light coming from that glowing piece of metal in his lab with the amount of light that was hitting it from the sun. But the mathematics part was that he realized that the total amount of light that the sun is emitting is absolutely huge. Yeah, let's think about that. The sun is out there in space, and it sends light out in all directions over the whole solar system. Only a tiny bit of that light actually hits Earth, and an even tinier bit of that hits Ireland, and an even teeny tinier amount of that hits his mirror and is bounced into his lab, and an even tinier amount of it hits his detector. So he had to be able to use mathematics to work backwards and figure out how much light must be coming from the whole sun if he knew how much was coming from that tiny bit. He was able to do that, and he came up with a value for the temperature of the sun. The value he came up with was 6,200 degrees Celsius. Now, before that, we said people thought that the temperature was somewhere between 1,500 and 5 million, so they really had no idea. He said 6,200. Now today, with all of our equipment and computers and satellites and all of this complicated equipment, we figured out that it's 5,500. He just had mirrors, yeah, and some light and some magnets, and he was only a few hundred degrees off. So we can really appreciate how he was able to use his ingenuity and his scientific thinking to come up with all sorts of crazy equipment to be able to measure something that was thought to be impossible at the time. So what I'd like you guys to think about is, what could you do today that people think is impossible now? And what sorts of mad equipment could you come up with that might be able to measure things that people can't measure now? And how you get to do that is by studying science, going into a lab, and playing around with all of the different types of material you can get your hands on today. So I hope you enjoyed that today, guys, and I hope you learned a thing or two about William Wilson. And hopefully you'll use that bit of knowledge to go on yourself and to learn all sorts of new things about science. Thanks so much for tuning in, guys, and I'm looking forward to seeing you on the next one.